As I'm sure you're very much aware, whether it be through the numerous adverts we see on TV or the very unamusing Christmas cards we've been receiving recently, now is the time of X plus Y-mas. See what I did there? Using algebra. And it seems that the only way to get through to people at this time of year is through associating everything with this time, Christmas. So, the following few videos will be combining the love of Christmas with the love of everything that is good in mathematics. Firstly, I shall be discussing the old, controversial question, is every single snowflake unique? Now the answer the majority of you people will be thinking, as well as physicists, engineers, and general non-mathematicians will think, yes. Yes, there are no two snowflakes in the world which are exactly alike. However, if you take this question from a mathematical point of view, the odds are very slim, yet are still very much apparent. And to a rigorous statistician, these errors cannot be ignored. So, allow me to break this down into the smallest cases possible. Essentially, the atoms which make up the water molecules, which make up the ice crystals, which make up the snowflakes. So at initial inspection, it seems that the only thing we need to worry about in this case are lots and lots of water molecules, which to the normal person can be very similar. However, there comes a point where the hydrogen atom can be replaced by something called the deuterium atom, which is the name of a hydrogen atom with an extra neutron. And this occurs approximately every 1 in 5,000 water molecules. Further to add to this, the oxygen-16 atom can be replaced by an oxygen-18 atom, which occurs in approximately 1 in every 500 cases. So we find ourselves with water molecules with differing sizes of molecules. So what do these different types of water molecules have to do with the formation of a snowflake? Well, approximately in every snowflake there are 10 to the power of 18 water molecules. If you don't know what this means, 10 to the power of 18 means 1 followed by 18 zeros. And as we previously discussed, 1 in 5,000 of these molecules contains a deuterium atom, which means that 10 to the power of 15 of these 10 to the power of 18 molecules are different to the original water molecule. Furthermore, we said that 1 in 500 of these contain the 018 atom, meaning that 10 to the power of 16 of these 10 to the power of 18 water molecules are in fact different. Did you follow that? I hope you've understood everything that's been said before now, because I don't intend on slowing down now. So now what we have to do is find the number of different ways that these different atoms can be arranged. And this can be done using the permutations function, and finding 10 to the power of 18 factorial divided by 10 to the power of 18 minus 10 to the power of 15 minus 10 to the power of 16 factorial times 10 to the power of 15 factorial times 10 to the power of 16 factorial. Those numbers seem very large, and indeed they are, to the point where that calculation becomes more than the number of water molecules there are on this planet. So what can we conclude from that? That there are more possible combination of these different molecules within one snowflake than there are possible water molecules on this Earth. That implies that it is very, very unlikely that we will ever find two snowflakes with exactly the same molecular combination. But almost isn't good enough for me. This extremely large combination of atoms is very analogous to the idea of shuffling cards. And what the theory states is, I will randomly shuffle a deck of cards as much as I want, nice and randomly. And the combination of which I create has never been created before in the history of the universe. To summarise the problem that we have deciphered, it is very, very unlikely that we will find two snowflakes which are exactly similar. Very, very unlikely. But to a mathematician, very, very unlikely is not a certainty. And only until we find a certainty can we be happy. So, what about you? Are you satisfied with the fact that it's very unlikely? Or are you going to be an intellectual person like me and question things you've been told? Merry Christmas.